Assessing exposure throughout the life cycle means taking into account the different stages of human life and how they may be exposed to environmental agents at each stage. For example, a developing fetus may be exposed to chemicals that the mother is exposed to during pregnancy, either through ingestion or inhalation. Infants may be exposed through breast milk, as well as from their immediate surroundings such as their living environment, food, and water. Young children may experience greater exposure through their behaviors such as crawling and putting objects in their mouths, and adolescents may be exposed to more chemicals through lifestyle choices such as smoking, drug use, or working in certain industries. Assessing exposure throughout the life cycle involves evaluating the risks of exposure to environmental agents at different stages of an individual's life. This includes assessing the risks for mothers and babies, infants and toddlers, school-age children, and older children. The methods used to evaluate these risks may differ based on the age group being evaluated, as individuals in different life stages may have different behaviors, susceptibility, and exposure patterns.
Longitudinal birth cohort studies typically focus on assessing the potential health effects of environmental, chemical, biological, and physical agents on individuals over a long period of time. The agents of concern selected for these studies are those that are most likely to have an impact on human health and may include pollutants in air, water, or soil, as well as other environmental factors such as noise or radiation. These studies aim to track individuals from birth or early childhood through various stages of their life cycle in order to identify any patterns or associations between exposure to specific agents and the development of certain health outcomes or diseases. Biomonitoring measurements involve the analysis of biological samples such as blood, urine, or hair to determine the level of exposure to environmental agents. This method of exposure assessment provides a direct measure of the internal dose of a chemical or its metabolites in the body. Biomonitoring measurements can be used to assess exposure to a wide range of environmental agents, including pesticides, metals, and industrial chemicals. The data obtained from biomonitoring can be used to estimate the potential health risks associated with exposure to these agents. This approach is particularly useful in longitudinal birth cohort studies, where repeated measurements can be taken over time to monitor changes in exposure levels and their potential health effects. Biomonitoring is also useful in identifying populations that may be at higher risk of exposure and informing public health policies and interventions to reduce exposure levels. Biological matrices such as blood, urine, and hair have been used to assess environmental exposures in pregnant women. These matrices can provide information on exposure to various chemicals, including pesticides, heavy metals, and flame retardants. Blood samples can be used to measure the levels of certain chemicals, such as lead and mercury, which can be harmful to both the pregnant woman and the developing fetus. Urine samples can be used to measure exposure to chemicals such as phthalates and bisphenol A, which are commonly found in plastics and personal care products. Hair samples can also be used to measure exposure to certain chemicals over a longer period of time. For example, hair samples can be used to measure exposure to pesticides or heavy metals over several months. Assessing exposure in pregnant women is important, as exposure to environmental chemicals during pregnancy can affect fetal development and may lead to adverse health outcomes later in life. Therefore, identifying exposure to environmental chemicals during pregnancy can inform interventions to reduce exposure and potentially improve health outcomes for both the mother and the child.